My name is Travis Spencer. Thanks for coming in here in my talk. There's a lot going on right now, so I appreciate you taking the time to come in here. I'm going to be talking about how you can protect microservices using phantom tokens, which is a flow or a way of implementing OAuth, which is a standard for protecting data using security tokens. I'm going to show you how you can combine that with NGINX to achieve that flow. So I work for a company called Curity, and we are an OAuth server company. So kind of like NGINX is a fast little server that implements the HTTP standard, Curity is a fast little server that implements the OAuth standard. And so I'm working here on OAuth every day with my colleagues, and this is one of the common patterns that we see deployed. So I'm going to talk about that, okay? Also, if you are interested in APIs, we are also organizing something called Nordic APIs, which is a blog and an API community. So there's other aspects of APIs like design and business models and all of that sort of stuff. And that can be a helpful resource for learning other aspects besides security as it pertains to APIs. So you can check that out. And if you can come over to Stockholm, I'll be giving a talk there on advanced OAuth. So if this is too basic for you, I'll do like a half-day session in October, going into real depth about the security aspects of OAuth. And there will be some basic ones too, if this is maybe more at your level. So be aware of that. You can also find some online resources. But today, what we want to talk about is two things. So first of all, I want to give you some high-level overview of different aspects of OAuth, because I'm not assuming that you know a whole lot about this, just so that we can have a level set and talk about how we can use this to implement the phantom token flow together with NGINX. Okay, so the second part will be the actual application and seeing that flow, and I'll do a couple of demos so that you can see those working. Okay. So first of all, let's talk about some OAuth basics. So what is OAuth? It's a protocol of protocols, or sort of a meta protocol that defines how to get tokens that represent end users. And so there's an authentication process that takes place, which you'll see and which we'll talk about. But the overall point of OAuth is to limit the sharing of passwords, to allow for revocation of access on a more granular basis, and to provide delegated access. So being able to say like this application or this mobile phone app can do something on my behalf. So those are really the scenarios that OAuth is trying to solve. In OAuth, there are 4 primary actors or entities that you need to know about. So there's the authorization server itself. So the thing that's issuing the token, authenticating the user, obtaining their consent. And then there's, of course, the end user themselves, which is called the resource owner. And then there's the API or the resource server. And then there's the client or the application. And those 4 together are really trying to say, like, get a token from the server, present it to the API, okay? So it's going to be in this part that we're seeing where the phantom tokens and the NGINX integration come into play. So it's Curity that would be issuing a token, whereas NGINX would be validating a token, okay? So just putting it in context a little bit. To the end user, the flow looks like this, where we have some sort of request of access. This could be like click to sign in. It could be automatic because the application notices you don't have a session. It could be lots of different things that could happen to request access. Then the end user is going to log in, and then they may or may not see an interactive user consent where they're having to authorize that third-party application to consume their resources. Both the login step could be automatic, like based on IP address, based on different things like that. So it also doesn't need to necessarily show something. But typically that's how the flow goes to the end user. So sort of stepping down one notch to what's going on in the wire, there's various message exchange patterns defined in OAuth, almost a dozen of them. The most common one and the one we're going to talk about today is called the code flow. And the way this works is when you click that sign in button, the user is going to be redirected to the OAuth server. The OAuth server is going to get the user to log in, and the user is going to perhaps interactively authorize or delegate their rights to that third-party application. And then you're going to get a very short-lived authorization code. This authorization code represents the end user's login and also their willingness to delegate their rights to this other application. So this will be forwarded in this code flow through the user agent back to the application, and will be presented on the back channel to the OAuth server. And the OAuth server at this point will issue access tokens that will live longer and can be used more than once. This authorization code is a nonce, a no more than once token, so it can only be used one time. This flow right here will typically authenticate this client application as well. So with the authorization code and the credential used to represent this application, then what happens is that both of this application and the user are authenticated, and the token itself is also possible when we finally call the API for the API to know who issued this token. So all of the entities, by the time we get way back in the data, can be authenticated, which gives the API a lot of information to decide if it should release the data or not, because it knows who did the authentication, it knows the application, it knows the end user, and then it can decide, should I release the rights or release the data based on these rights. To help with that, we have something called scopes. Scopes are a group of claims. This is a concept in OAuth that can allow for more fine-grained permissions to be in the access token. So you're not just saying, okay, you have a token, you can come on in, but then you can look in the token and see based on maybe like groups or attributes what you should be able to do, which data you should be able to act upon. So these claims are statements that the OAuth server is making as true that the API can consume, and then if it's willing to believe those, decide if it should release the data or not. There's no standardized scopes, but OpenID Connect, which is a related standard that builds on top of OAuth, it does define some scopes. We have different kinds of tokens. So we have something called access tokens and refresh tokens. I like to use an analogy to explain this, where an access token is like a session and a refresh token is like a password. And what I mean by this is, like, if you access a website, it's HTTP, it's stateless. So the first time you access that application, it needs to create some sort of state. Otherwise, it's going to have to log you in over and over again. So that refresh token, you can sort of think as the password, where it's creating or bootstrapping that session. And then after that, you're no longer having to bother the user. That session that ends up being created like that is what would be analogously the access token. So once you have gotten an access token, you can start calling APIs. You don't have to log in again. You don't have to do anything again. But after that access token expires, because they tend to be pretty short-lived, 15 minutes, 60 minutes, something like that, so they don't have to bug the user again to log in, you can issue the authorization server can issue a refresh token, which can be used to get a new session that will last maybe another 15 minutes, another 60 minutes, like that. And so it sort of bootstraps a new session. We also have different profiles of tokens. We have something called bearer tokens and holder of key tokens. Bearer token is like a bearer bond, like a cash. Like if you find it, you can use it. So there's no tie between the one presenting the token and the one to whom the token was issued. So if you're lucky enough to find $5 outside and you go to Starbucks, you can spend it and the barista just accepts it. Doesn't matter that you found it on the street, right? But if you need to have more assurance that the one to whom is presenting that credential to the API is actually the one that was authenticated and went through that flow that we just talked about, you might want to use something like a holder of key, where the token is bound to that entity. And that would be more like a credit card, right? If you find my credit card outside and you go to Starbucks, you don't know my PIN number, or their signature is not going to match, or you're not going to have ID card that says that you're that person. So the barista will hopefully deny your transaction. So it's the two sort of ways that we can do it by using different profiles of tokens. So we also have different types of tokens. OAuth doesn't define any specific type. It allows for this to be what you would need it to be. So you can have legacy types like WS security tokens, SAML tokens, but you can also have more modern token formats like CBOR web tokens. You can also have, of course, opaque GUID tokens, which we'll talk about, and JSON web tokens. Briefly, JSON web tokens are coming from the English word jot, like to write something quickly, because they're very compact, small tokens that are meant to be passed around in HTTP headers and query strings, really made for mobile scenarios, for compact scenarios. They can be encrypted, they can be signed, they can be unsigned. They're not the only kind of token though to be used with OAuth, even though you hear about them most often. Is this thing? Yeah. We can pass tokens in different ways also. So we can pass tokens either by value or by reference. So sort of another analogy from programming speak, like we can pass data on the stack by value, or we can pass a pointer to some location where that object is on the heap. If we ever want to access that data, we have to dereference it. So same sort of thing. We can have a token where all of the user data is in the token. That's a by value token. Or we can have just be a GUID, some sort of unique identifier that points to the user information. But in order to get that, we have to dereference it. And the only one that can dereference it then is the OAuth server, since it had the unique identifier that points to that user information. So just briefly before I wrap up on the OAuth basics, I want to impress upon you the wrong ways of using OAuth and the right ways of using it. So OAuth is not an authentication protocol. It says nothing about how the user should be logged in. Like I mentioned, the example of the IP address, or you could log in with username and password. You could log in with smart cards. It doesn't much matter as far as the specification and the protocol is concerned. So it's not at all an authentication protocol. It's also not a federation protocol, and it's not even really an authorization protocol. The ultimate one who makes the authorization decision is the resource server, the API. So what is it? It's a delegation protocol. So it's really about saying that some user wants to, or some application wants to do something on behalf of a user. Should that be allowed or not? Okay. So I'll give you a quick demo of the code flow. So I'm going to be using this tool called OAuth Tools. We provide this. It works with any OAuth server, in fact. And it's sort of like a Postman, but just for OAuth and OpenID Connect. So you can use it to do different flows and to do different things with it. So we just talked about the code flow, so let's go ahead and do that. So I can do all these different flows here, and I'm going to do the code flow. And just like in Postman, you have different environments. I have one set up here with my different client applications and where my server is and all this stuff. Okay, so I'm going to go here and start the code flow by picking one of my clients that can do that flow, one that I call client 1. And I'm going to pass one of those scopes. And this is going to be used to authorize my API access when I start calling the API through NGINX. So here I have requested the API or the OpenID scope. So what this ends up looking like, at least this part works. So this would be the curl command, but you could do this in whatever programming language you wanted to, where we're going to go to my OAuth server, which I put here at ngrok, so I could actually serve it from my laptop. And then there's an endpoint to do the authentication and consent. I have information about my client ID, and I have that I'm requesting some certain scope. I have a response type that tells the OAuth server that the code flow is being done. And when it's finally done, I should be redirected back here to OAuth Tools. Okay? So, and just in case I have a login session, which I probably do, I'm going to force myself to log in so you can see the... Yeah, so here, this part is, again, outside of the spec. I just tried to get the application authorized, but in my configuration of my setup, in order to do that, the end user has to log in. Okay, so I'm going to log in as John Doe. My password manager has remembered my password, so I'm going to do that. And then remember in the flow, if you don't remember, let me bring it up here. Remember in the flow, we talked about how afterward we come back to the client and we get that one-time usage authorization code. So, and present it to the token service. So now that's the part of the flow we're at now. So I'm going to come here and I'm going to redeem that code. It's just this little nonce here. So I'm going to do that. And here I get some tokens. So I get 3 tokens in this flow. I get the access token, which happens to be GUID. Remember, you could have JSON Web tokens. You could have SAML tokens. You know, I said you could have those reference tokens, or GUIDs. So I have one of those. I have a refresh token. Remember, this is sort of like your password, so you can bootstrap a new session. So if this one expires, which it's gonna as I keep talking, I could, rather than have to do the whole flow again and get the user to log in, I can just call the OAuth server with this and get a new one of these access tokens, sort of prolong the session. And then I get something called an ID token. which is defined by OpenID so that this application can know who the end user is and not just the API. So the access token is intended for the API. Okay, so that's a little bit of OAuth basics. And I hope that will help you to understand more the second half. But let's look at that now. So microservice is kind of a big topic as it pertains to OAuth. In this, I'm going to be looking only at the ingress part, not the service mesh of all the microservices behind the ingress. So if you're interested in how would you secure the mesh of microservices in the back end, you can come and talk to me afterward. But as you're coming in, what we want to do is we want to switch the tokens as you're flowing into the network. And that flow is called the phantom token flow. And this is just a made-up name that we created because it makes it easier to talk about so we know what we're talking about. But you're not going to find this in any specifications. It's just a prescriptive pattern. But how does that pattern work and what does it mean? What it means is that we want to take a by value token that can be obtained by dereferencing a by ref equivalent. Whoa. So what I mean by this is we have the GUID token, and the only way that you can find out the user information is by dereferencing it. Remember our stack example, like a pointer to the stuff on the heap. We want to get that. We need to dereference the pointer. So we want to dereference this token, but what it dereferences to is a by value equivalent. And a by value token has all of the user information inside of it. And the most common one to do would be a JSON web token. And the JSON web token is signed so that it can't be tampered with, so that as it passed deeper into the network, the backend microservices are going to know that this came from the OAuth server that it trusts. Okay, so let's look at that flow as it relates to the one we just went through. So the user is redirected to the OAuth server. You saw that, right? And I entered in John Doe and I logged in. So that's sort of step of the flow. And then it comes back here after the user logs in, and we dereference we exchange the authorization code, and now we have this this by reference access token, a GUID. And so in a normal exchange, you would just pass the token directly back to the API. But then the API has a bunch of work to do to actually do that dereferencing. You don't have to do that all the time. So usually when this application, this mobile app or this web app is calling an API, it's never calling it directly. There's some different intermediaries, there's different layers in there. We have a reverse proxy in there almost inevitably. So this thing is ideally positioned to do that switch for the microservice. So what can happen is, as this opaque GUID, this reference token is coming and flowing through here, we can take advantage of the ingress position of the reverse proxy to switch that GUID over for the by value reference token, or a by value access token, and then forward that to the backend microservice. Because now the microservice will have inside of it all the user information that would be necessary to do its job, or at least its job, perhaps not the job of the microservices is calling downstream, but this is a start for the first layer. Like I said, I won't go into the mesh part. But so that you can think of this JWT sort of as a phantom, right? So that on the outside, it doesn't exist. It's only in the back end that we have this specter floating around. Okay, so I'm going to show you a demo of this. And in the demo, I'm going to have OAuth tools again, like you saw before. I'm going to call an API that is fronted by NGINX. And NGINX is going to switch this using a module that we've created and forward the JSON web token to the backend. Okay? So I'll start by showing you the NGINX configuration because I'm in an NGINX show, so I have some people here that would actually appreciate that, which is nice for a change. Okay, so here's what we have. We have the HTTP, we have the server, so it's running on 8080, and then for everything, it's going to forward it to the backend API, the real API. Okay, and I put some marker here so we can see that it's working and not just me with smoke and mirrors. And here is my module's configuration settings. So it's called Phantom Token, aptly named according to the pattern I talked about. So in the Phantom Token module, we're going to call over to the Curity server and authenticate as a client that can do this flow, this introspection flow, and a credential there to do that. And the location information of that is down here. So my Curity server is running on localhost 8448, and the introspection is there. And when I get a call without a token, I'm going to return information about how the user can authenticate and the scopes that they need. So I provide some configuration here. So let's just make sure, I didn't test this before, which was maybe not too wise. But let's just check my internet connection by going here. And you can just go to github.com/CurityIO. And then if you look here, I think it's pinned. Yeah, here it is, NGINX Phantom Token Module. So you can find the source code here, that pattern I just talked about, the different config settings that you have there, examples. And then if you want, you can set it up with caching also, which I'll get into in a little bit. So here's some sample configuration to show, or here's some sample configuration that shows you how to do the caching and things like that. Okay, so it also talks about building and all of that and downloading the module with pre-built ones that work with NGINX Plus and stuff. But you can go there and find that on that GitHub repo. Okay, so now let's go back here. So we did this flow and we had this access token, right? So we want to call through to the API or to NGINX that is actually running that module that we just looked at the configuration and see the switch as it calls to the backend API that only wants a JSON web token. So the flow that we're going to do here is call external API. And if I can remember, even with those lights blaring down on me, it's api.ngrok.io, and it was called Jot, hello Jot. And I'm going to do a get here. And the token that I want to use was this one, which ended in, or started in 46C. So we picked this one from the previous flow, which was 46C. And now here's our API call. So we're going to go to there, which hopefully I remembered it correctly. And then here we do this authorization bearer and then the GUID. So this whole HTTP authentication method is defined in a related spec to OAuth RFC 6750, which just will trigger the Phantom token module to say, okay, look, I got this. Now I'm going to call over to Curity with this part of the header value and try to switch that for the Jot token. So let's see if this works. No, what was the actual API called? It was called this one. Okay. So that token is expired. So NGINX is telling us expired. So remember I was talking to you about the refresh token. So instead of doing the whole login flow, we can take that refresh token and get a new access token. So I can just click this button in this tool and it gets me a new one that starts with 3302 something something. So if we go back here now and use a non-expired one, yeah, I think this one. Now let's call the API. Okay, so now we got the response back. And here, what the API is actually doing is echoing the headers. So we can see that I'm not lying to you. And then it prints the logged in user. So when the API was called, it got called with an authorization header bearer and then this EY Anything here that starts with EY, it's like you can almost guarantee it's a JSON web token because that's the base 64 encoding of a left brace. So it's getting called with the JSON web token instead of with this one. So the Phantom token module called over to introspection using that credential in the NGINX configuration, ended up getting the JSON web token, which it forwarded to the microservice. And then here's our little marker. So when it did that proxy pass, it set the header. And so we know we really went through NGINX. And then when we got over into the API, it looked inside of here and saw that the user that logged in was John Doe. And we can see that these two go together. If we just do another little flow here, which is decode Jot, and we just paste this, you can see that inside of here is the user John Doe. Does that make sense how all those dots connect? Okay. Let me switch back to slides and talk about some of the benefits and the drawbacks of this phantom token approach. So we end up with a smaller regulated space. So since the days of XML firewalls and tokenization of credit card numbers, we've been doing this for the last couple of decades. This idea of taking some sensitive information and replacing it with unsensitive information that looks the same. So it's the same sort of trick we've been doing for a really long time. As a consequence, the mobile application, the front-end web application, they're not regulated because they don't have any personally identifiable information. So it's a lot easier to conform to those requirements. It's also not possible for the client application to access any PII because there isn't any there. So the alternatives to this would be to encrypt the JSON Web Token. But then we're putting the decryption inputs into the hand of the attacker and saying, I dare you to decrypt this. And if there's a flaw in our encrypting of that web token, it might actually be possible to decrypt that. So with JWTs, we also only need to compromise the transport. And we all know about a number of different SSL issues that have gone over the years. So if we rely only on transport level security, we might be making ourselves vulnerable. If it's a GUID, it's still a bearer token in many cases, so we have to be careful, but at least then there's no information just by looking at the unencrypted transport. Also, the front-end applications, they can't take a dependency on the contents of the token. So like if you have a JSON Web Token as your access token, even though it's meant for the back-end API, your front-end React developers or Angular developers might start grabbing all that information out of there and build a dependency on that. So as you want to change your back-end API, you might end up breaking your mobile app or something. And that's not going to make you very popular at lunchtime. So we also have that the microservice in the backend might store the token. Like my little API that I created, it might actually store the JWT token and become stateful like that so that it can work over it. And that's fine. It will never dereference to that after the reference token has expired. And I'll get to caching here in a second. Standard compliant and vendor neutral. So you saw us do it with our phantom token module. That phantom token module app actually implements something called introspection. So that could have been anyone's OAuth server actually, even using our NGINX module. Drawbacks, you have to dereference it. So you got to go over the network to do that. It's the obvious drawback. So you can cache it as a solution to that. So the expiry information, you can't really see that because we don't see the NGINX call to the Curity server, but the Curity server responds back with normal HTTP caching headers, and we'll say the NGINX can cache it so long as it doesn't become NGINX doesn't cache it after the token has expired, right? Like you saw that my token expired. If that was still in NGINX's cache, then I could keep making API calls even after it expired. So when Curity responds, it will actually have normal HTTP caching headers there to say, okay, you can use it for the next 41 seconds, 38 seconds, 35 seconds. So that NGINX will never use it too long. And by using normal caching, NGINX just does the right thing based on that configuration you saw in the GitHub configuration sample. Use a fast reverse proxy. So as opposed to a slow one, I mean, we're at an NGINX conference, so I don't have to sell you on using NGINX, which is a great one for doing that. That will help us with this need to go and make this sideways call. And then we can also use preemptive caching. So what do I mean by preemptive caching? What I mean by this is that the OAuth server can send to NGINX or the API gateway the by value phantom token ahead of time and a hash of the opaque by reference access token and the expiry. So now it can put these three things together and actually save it in the cache so that later when it sees the by reference token coming in, it can hash it again, find that using the hashed cache key associated with the phantom token and then forward it. So this inevitably creates a race condition where maybe the cache isn't loaded yet. So in that case, we'll just make a call over to the Curity server, the same as we would do with responsive caching. So this one's pretty obvious and pretty easy to do actually with a server like Curity's that can fire events and just call over, get that and store it. The drawback of this one is that you have all your tokens right there in the cache inside your NGINX server, which might be like in a DMZ or in a demilitarized zone. So it becomes a pretty attractive honeypot. And the solution to this is to split the token so that you don't have the entire token in the cache, but only part of it. And the other part of it that will be combined with what's in the cache will only be presented when the API is called. If that splitting is interesting to you, grab me afterward and I'll show you. I have it here in the slide deck, but didn't want to go too deep. Oh, this thing doesn't work. Right, so if you want to talk about that, grab me after. So in summary, we have different actors in OAuth. We have various flows. I show you the code flow. We have different kinds of tokens. JSON Web Tokens or JWTs is one example, but we can have opaque reference tokens. We can pass tokens in different ways. And we need to use OAuth appropriately, so it's about delegation. And when we do use OAuth, we can combine that with phantom tokens to make secure ingress of microservices. And makes it very easy with NGINX and Curity combined together. If you want to learn more, you can go to curity.io. The module which you saw again is at github.com/curity.io. You can search for it there. You can download Curity from here, and you can come over to our booth, register for Nintendo Switch, and ask more questions or share some thoughts if you want to. That's all I have.